The first computers were people. This is back in 1757. There were three mathematicians based in Paris manually calculating when Halley's Comet would re-enter. It took them 4 months, and they got it right within a month. Going forwards in time, Charles Babbage absolutely hated this form of manual calculation and labor. His idea that set forward a lot of what automation is around the ideas of economy of time, reducing the amount of time it takes to do something, error, reducing the errors, and also intellect, his idea of a human should be free to pursue a higher form of thought, whatever that is. If we look at the early forms of diagrams around automation from von Neumann, from Babbage, and from Goldstein, you'll notice all these processes have absolutely no representation of a human. This is very much their idea around trying to remove and extract the human from what automation is, which we refer to as the vanishing point of automation. We're asked to imagine that automation at its roots, there are absolutely no humans present or visible. It is simply a machine operating in itself. Excuse me. Yeah, next slide. Yeah, if we look to Turing's work, we have this other strange paradox that within Turing's work, the idea is that all modern computing can be reduced to a human with a piece of paper, a pencil, and a rubber. Why would they need a rubber? They make mistakes, okay? And you also notice that there is a programmer in that diagram. So even Turing's idea of this abstract human, there were still programmers involved in the system, even if they were made invisible. If we look forwards and we look at the evolvement of software, we discover that all these attempts to remove the human still leave us in this situation where actually it's quite hard for a human to tell a computer what to do, and it actually does it. And as we evolve through this time, there's actually a huge amount of time that passes, and we discover that software does not work. And so software engineering was born as a response to this crisis, to try and work out how we deal with time and how we deal with error. A lot of the ideas around universal modeling diagrams, trying to turn programming into a process of creating architecture diagrams that then generate code. So code is not really about language, it's about diagram forming, which was a terrible idea. Computer science, which, bless it, isn't really a science because it's got the word science in the name, came up with lots of ideas around logic, around formalizations. Unfortunately, it was terrible. While it did great things, it was terrible at considering humans' language translation, which are the fundamental precepts of programming and automation. Funny enough, something came along called extreme programming. It's crazy that it had to be called extreme. That really started to look into the idea that maybe programming was actually about the language, about conversations, about two people sitting talking to each other might be better at automating a process than, say, just one person, and that the words that we use actually matter, and we have to spend a lot of time thinking about those and how we translate them in models into the real world. When we find we treat algorithms as tools implemented on a stack of abstraction, we miss all the important things around language, around translation, around biases, and continue to make mistakes, assuming these things are perfect expressions of automation as opposed to flawed human expressions of automation. To deal with the idea of ideology in software, this presentation is not a presentation. You are looking at a computer, and layered on this is lots and lots of software, ultimately to give you looking at a set of slides, which is not a slide. So this is the idea that it's abstracted from the implementation method. We take this forward and we look at some forms of AI and machine learning. We start to see the building continuing. Computers are smart, learning, intelligent, the brain, and also magic. These equivalences are not true in terms of a human, right? There is no machine that is smart, learning, intelligent, certainly not magical. What they are starting to do, if we saw initially we had that invisibility of the human, trying to remove the human from automation, what we have now is that empty hole, that gap that Turing talked about, the abstract human, being anthropomorphized as a human. We're being told that these machines are humans, which is, again, a massive leap in ideology. If we look actually what programming and machine learning look like, the left there is just what programming is. A human sits down, writes some rules, and it gets executed. Machine learning, wow, that's cool, it exploded, is effectively a process of a human writing rules, and then a machine takes a huge amount of data, and it then executes that and generates machine automated rules. In fact, this form of programming is more fundamentally human labor intensive than any other form of programming before it. The amount of data, artists who are working machine learning spend their entire time creating these beautiful data sets, massive data sets, that are then used as training. So in fact, to say this is not human is a deep, deep misleading. Wow, that's so cool. That's effectively as a quote from Error, right? This is a simulation going wrong. This is effectively a quote from someone at Google saying that artificial intelligence is not intelligent and it's not artificial, it's human labor. The idea that it's a lot about human labor and human work. What we find when we try and build tools that try and solve error, we avoid actually trying to understand what error is. And we continue to make the same mistakes. In machine learning, going back to the automation, error leaks. It just gets redirected elsewhere. And suddenly we find the machines have biases, they make mistakes, and those errors are just replicated elsewhere. Maybe magic is a good analogy for machine learning and AI, since it requires a huge amount of practice, a huge amount of labor, and then through a sleight of hand is made to appear as if it were magical, when in the reality it's very mundane, very boring, and actually quite stupid. For me, I want to rebrand automation and kind of challenge that idea of a economy of errors that Babbage talked about, and think about it as an economy of creativity. To think the idea that as soon as we smash that idea of not being human, we can start to see automation as a tool of self-expression, of creativity, and for me personally, most importantly, is a way of challenging visibility, to try and explore and understand how humans interact with the machine and how that affects us creatively and how it affects our visibility creatively. Thank you very much.